let's reset, and let's now clean up our code a bit. So we're done using this for now. So you can delete this or save it for your reference. Let's go back to our original path of 2 points. So point 1 and point 2, and we're adding them in the for loop. Compile the code, run your simulation, and you can see the vehicle is traveling on a straight line. Now, by default, the interpolation of the vehicle's path is 0, so that's why you have kind of a linear motion to point 1 and a linear motion to point 2. But you can change this interpolation value, so reset your simulation, and after you define the speed of the vehicle, let's now set the interpolation property of the vehicle to 0.35, because by default this value is 0, and that's why you get the straight lines. So 0.35 should give us a slight curve in the vehicle's path. Compile your code, run the simulation, and yep, whoop whoop, whoop whoop. So we get a nice little curve to the out when the vehicle accelerates to pass through P1, because it's not going to skip P1, it still has to go through it. And then the vehicle curves out again to stop at P2. Let's reset and see what happens when we use an interpolation of 0.8. Compile the code, run the simulation, and we get a much bigger curve out, so the vehicle decelerates, slows down, and then accelerates quickly to go through P1 and does the same to end up at P2 here. Reset, and whenever you are using an interpolation value greater than 1, you're going to see some funky movement or some chicken dancing from your vehicle. So let's use 1.5 for interpolation. Compile the code, run the simulation, and you can see the vehicle is going all over the place. So in most cases you probably don't want that. I find that 0.25 or 0.2 to 0.4 gives you, some good results. But let's actually change interpolation back to 0. And if we compile our code, run the simulation, we are back to the straight lines.